Alright, let's move into problem number 33 now. So this problem talks about the cancelling fractions. So if you look at this example, 49 by 98, and if you see 9 as a common term, then if you cancel 9, then that becomes 4 by 8. And 4 by 8 we know is 0.5. So in this case, 49 by 98 is equal to 4 by 8. We might think that, okay, if we remove 9 as a common term, this becomes same. Now there are other examples like 30 by 50 is equal to 3 by 5 where we're cancelling 0, and this is called the trivial examples. So we are not interested for this kind of trivial examples. That means we are interested for this kind of example where the second term or the first digit of numerator and the second digit of the denominator, if we cancel them out, then that becomes our equal. Okay, so we'll have to find out such an example. The problem says there are exactly four such terms available. Okay, for all the two-digit numerator and denominator, and the fraction should be less than 1. And we'll have to find out other 3. This one is one of them, and we'll have to figure out other 3. Okay, let's see how we can do it. So first of all, let's figure out our number is, let's say, 98. So if I want to find out the 9, the number is 49 divided by 98. Okay, let's say I take 49. And how do I get the 9? I can just modular division by 10. Okay, and then how do I get the 4? I get 49 integer division by 10. Now for the denominator, I want to get the first term, so it should be opposite. From 98, in order to get 9, we will have to integer division by 10, and in order to get 98 modular division by 10. Okay, so now let's create a loop. Okay, and I'll say numerator as a list, I'll say denominator as a list, then I'll just try this for I in range 10 to 100, for j in range 10 to 100. Well, actually here what we could do instead of starting from 10, we can do it like this, I plus 1, because our numerator and denominator, it should be less than 1. That's what problem asked. Okay, so that's why a j should be, because I by j we want to do it. Now if you want to find out the shorter version of the numerator, that will be like this, I modular integer division of 10, then common one will be I modular division of 10, then denominator will be, because you remember the denominator will be here first term, so that should be j modular division by 10, and common 2 will be j integer division by 10. Okay, so once we have got that, then we have to check our condition. So we want to check if I divided by j equal to numerator divided by denominator, and common one equal to common 2. And yeah, if this condition happens, let's print ing. Let's see what happens. ing. Okay, here it should be equal to division by 0. Okay, so here denominator we might get 0, so we'll have to remove that. Okay, denominator equal to not equal to 0 and this. Okay, so we got 3 digits. We are looking for one more, and okay, yeah, this is a problem here. Common 2. Okay, yeah. So we got 4 answers, and you see one of them is 49 divided by 98. Now we want to save the numerators and denominators. Okay, so numerator dot append. I want to do numerator and denominator dens dot append denominator. Okay, so we got this number. Now let's see our this numbers here. So we got this. So we have all ones except one. Okay, now problem is also asking the numbers with its shortest term. So basically what it is also asking, okay, two things we can do. We can just multiply all the numerator and all the denominator and divide it, or alternatively we can do one more thing. We can basically, okay, so in order to make it the shortest term, what we could do is, here you see we have 4 and 8. Okay, in this case what we can do, we know this 4, this is denominator is 8 and numerator is 4. We know the 4 is divided by this numerator. Okay, it's totally divisible. So instead of saving this, we want to save this as 1 and we want to save this as 2. And how we can do that? Let's create another condition. Okay. The condition is this: if denominator is equally divided by numerator, that means this is equal to 0, then what we want to do is we want to create denominator as denominator integer division of numerator. Okay, and numerator becomes 1. So let's check that. Now if we check our numerator, we have found 1 1 2 1, and then we have found 4 5 5 2. Okay, now here we have only 1 2, and then we have 2, and this 2 and this 2 will cancel, and what remains is 4 5 5. That is 4 into 5 into 5, that becomes 100. I think 100 will be our answer. But if you want to do it in it programmatically, what we can do is we can write another loop. Okay, we can just do the multiplication. Basically, we'll have to multiply all these 4 numbers, and we'll have to multiply all the numerator, all the denominator, and then we have to do the integer division. So what we can do is, I can write down a loop. Let's say I'll say numerator multiply is equal to 1, and I'll just do this. Okay, let me just clear this out. Okay, I'll just do for I in nums, num multiplied star equal to I, and similarly I'll just copy this. Let's say den multiply and dens. Okay, so now I got this numerator multiplier and denominator multiplier. So this is 2 and denominator multiplier is 200. So if I just divide by this, that becomes 100. Okay, now let's check if the answer is correct. Yeah, our answer is correct. Thanks for watching. Coming up next is problem number 34.